differentiate to get cos x? That's straightforward, just sin x, right? So I'm just going backwards, all it is. It's exactly like the word say, antiderivative. You're undoing the derivative. What's next? Tan? So that's more difficult because we didn't differentiate anything and ever get tan out by itself, correct? So let's have it in the list here, which I doubt they do. They're sure to, but I don't think we need to. Yeah, they don't have it like. No, that's usually for next semester. All right, forget tan. But what derivatives did you know? You knew what? Secant squared x. If you saw that, you would know the answer is tan x plus c, correct? Right? What do you differentiate to get secant squared? You differentiate tan, right? And it could have an arbitrary constant attached to it. So I'm just writing out the reverse roles of what we had before. So let's see, sine, cosecant, cosecant. So if we had a cosecant, cotan floating around, then you would know the answer is what? Negative cosecant x plus c. Just undoing the derivatives we already know. Secant tan. Inside the integral symbol, you know it's just secant plus some arbitrary constant. And if you saw cosecant squared inside here, you know the answer is negative cotan x plus c. And it's just reverse derivatives, right? It's reversing everything we know already. That's all. Is that? Can't hear what you're saying.
What's the c?
Oh, it's arbitrary constant. Because this question is saying, what do you differentiate, what do you take the derivative of to get cosecant squared? Well, negative cotan, really. But negative cotan plus 1, if I take its derivative, the plus 1 would go away, and I would still get this derivative inside here. Right? So every one of these always has a plus c on it. You could have any number here, and it would still be a true answer to this problem. Always plus c. Anytime you see an integral symbol that does not have anything there, no limits of integration. Anytime it's just there like that, you know, you put a plus c, append it to your answer. I just write a few more. I mean, you guys should know these. Here's an important one that this rule does not cover. Here, n cannot be negative 1. You cannot have x to the negative first in here and apply this rule to it. So since you can't use that rule there, and you'll see why in a second, what is the answer to this problem? Natural log. Not only natural log, but the absolute value of the input, right? ln of absolute value. I'm not going to explain that to you right now. If you want to know, I'll tell you. But just know that anytime you take the antiderivative of 1 on x, you need to have the absolute value on the x. Okay? As opposed to when you usually take derivative, you just take d dx of ln x, then you write 1 over x without any absolute value symbols at all. Okay? So when you're going in reverse, though, I'm not going to explain to you at the moment because it'll just take too long, then you're going to introduce an absolute value symbol on the input of the natural log. Okay? Necessary. All right. What about if you want to undo e to the x? Which is the easiest one to undo. What is it? E to the x. All right. What do you differentiate to get e to the x? Itself. You have an arbitrary constant there. What other function you have? Let's make one, right? Okay, so we'll do a few practice problems here. Let's get a think about these, and then there's a couple application problems we need to do, and one of them is to tie this on your exam. Make sure we get to it. Just remember, all you're doing is trying to undo a derivative, so sometimes it takes real thinking. It's not always formulaic. You have to really think about it sometimes. And sometimes you have to take a chance and actually compute a derivative and see if your answer matches up. And if not, then alter a little bit. Those of you that don't know, do substitution. So let's take number 14. We have find the antiderivatives of the following function. Okay? G of x, we need to find its antiderivatives, which is the work we just did a second ago, those formulas. It's negative 4 cos 4x. Negative 4 cos 4x. Figure out what function I differentiated to get to that point. What did you take the derivative of to get to this? Well, you know it must have involved what? What do you take the derivative of to get cos? So there must have been sine somewhere, right? So the antiderivative of negative 4 cos 4x, you always put the dx on there, right? You just want to take the antiderivative of this. And when it says find all antiderivatives, when I say all, then it says, make sure there's a plus c on there. That's all is saying. It says all antiderivatives. Just put the plus c on there. Okay, so let's see. It has to have sine 4x in it. Agreed? I must have taken the derivative of sine 4x. Now maybe there's some other stuff on there, but it's got to have this. So now let's just think for a second. If I took the derivative of sine 4x, just like this, what would you get? You get 4 cos 4x. Agreed? You'll be able to do a chain rule pretty fast in your head, right? 4 cos 4x. So what's the difference between our answer and that answer then?
Negative.
Negative. So put negative on there.
Wait, what do we do?
So we knew that to get to a cos 4x, we did the negative 4 for just a second, but to get to the cos 4x, we would have had to have started with the sine 4x. That's for sure. So now what I do is I take the sine 4x and I differentiate it in my head very quickly, or on paper, on the side, right?
Okay.
So what do I get? I get 4 cos 4x, right?
Okay.
So how does that differ from what's in here? The negative alone. The negatives only change. And we know that derivatives do not affect negatives, right? They slide right past that negative 1 constant multiple. So it must be that my answer needs to be the negative of what I have. That's what I was saying. You can take a derivative very quickly and see how it matches up and just adjust when necessary. Okay? So this was just an adjust of a negative is all we needed. Number 18.
Plus constant.
Say again, ready?
Plus constant.
Oh, very good. You said all, right? You gotta make sure I have all of them. Negative 6 z to the negative 7. They called it h of z. Negative 6 z to the negative 7. So find all antiderivatives. So you need to take the antiderivative of negative 6 z to the negative 7. And use dz instead of dx because the variable they gave us was c. Okay? Just stick with their variables. You should know in general that a multiplicative constant moves outside of this symbol, just like outside of limits and outside of derivatives, if necessary. So I could approach this and ignore the negative 6 for a moment, pull it out, and apply my antiderivative to z to the negative 7. Since I have a formula for z to the negative 7, right? It's not up there anymore, but whatever. Okay? So what was the formula for a power? I raise the power by 1, and then divide by the new power. Right? That's the formula for powers. So this answer should be the same negative 6 that works on the outside, times, if I raise the power up by 1, it will be z to the negative 6. I've got to divide by the new power, negative 6. Plus c. Now I just simplify where possible. So negative 6 and negative 6 cancels, and I have z to the negative 6. Okay?